Today, we're going to talk about something that could genuinely change the game for personal health. It's a pretty groundbreaking algorithm that's designed to run on something as simple as your watch and detect dangerous heart conditions in real time, like as they're happening.
So, to really get this, we first need to understand the huge problem this technology is trying to solve. And it all starts in a place where you'd least expect a problem, the intensive care unit. Okay, so picture this. You're in the ICU. It's high stakes, and heart monitors are beeping constantly. But here's the thing the clinical staff have to deal with. The huge majority of those alarms, they're not real emergencies. Nope, they're usually just triggered by a patient moving around or a sensor getting a little loose. And this creates a really dangerous situation called alarm fatigue.
Just let that number sink in for a second. 86%. When nearly 9 out of 10 alarms are false positives, people, even highly trained staff, can naturally become a bit desensitized. And that could, potentially delay their response when a real crisis hits. And this really gets to the heart of the challenge. On one hand, you've got these incredibly powerful ICU machines, but they're way too complex and way too sensitive for just, everyday life. And on the other hand, you have these super convenient wearable devices, but they just don't have the computational horsepower for really complex diagnostics. So the goal here is to get the intelligence of that ICU machine onto your wrist, but without all the false alarms and without needing a supercomputer to run it. So how do you even build a smarter approach? To crack this problem, researchers had to come up with a totally new way for a tiny device to listen to the rhythm of a heart. And it all starts with a pretty simple concept, a time series. If you've ever seen an ECG readout in a movie or a hospital, that zigzagging line, that's a perfect example. It's really just a string of data points. In this case, your heart's electrical activity measured over time. Now, if we were to zoom in on that line, we could grab the unique shape of just one single heartbeat. In data speak, that little continuous piece of the time series is called a subsequence. And this little shape, this is the basic building block for everything that comes next. So, how do you spot when that shape changes? Well, the old way was basically brute force. You'd create something called a distance matrix, where you literally compare every single heartbeat shape to every other heartbeat shape. As you can guess, that's incredibly slow, it eats up power, totally impossible for a watch. But the new way? It is so much more elegant. It's called the matrix profile. So instead of comparing everything to everything, the matrix profile creates this really simple and efficient cheat sheet. For every single heartbeat shape, it just finds its single closest match, its twin, you could say, somewhere else in the data. And then it just makes a note of how similar they are. That's it. This brilliant shortcut is the key that unlocks real-time analysis on a low-power device. And now we get to the real aha moment. So we've got this clever cheat sheet of heartbeat twins, but how do you actually use that to spot when the heart's rhythm changes in a dangerous way? I mean, that's the crucial question, isn't it? It's one thing to have a list of lookalikes, but detecting a fundamental shift in the pattern, what the researchers call a semantic change, that's the real magic trick. And the answer is a beautifully simple and powerful algorithm called FLOSS. And its secret weapon is this idea called arc counting. I know it sounds a little abstract, but it's actually incredibly intuitive once you see how it works. Okay, here's how it works. For any given heartbeat, we know the matrix profile finds its twin, right? So imagine drawing an arc that connects those two twins. Now, when your heart rhythm is stable, most of these twins are pretty close to each other, so you get this dense web of overlapping arcs. But, and this is the key, when the heartbeat's shape suddenly changes, like during an arrhythmia, these new, weird shapes can't find any twins in the recent past. All of a sudden, the number of arcs crossing over the present moment just plummets, and that sharp drop in the arc count is the alarm bell. It's the signal that the rhythm has fundamentally changed. So this all sounds absolutely brilliant in theory, but you know how it is in science. The real question is always, does it actually work with messy, unpredictable real-world patient data? Well, these researchers were incredibly rigorous about it. They didn't just take a guess at what the best settings would be. No, they built a system to run thousands of tests, automatically tweaking all the different parameters to find the absolute best, most optimal configuration for detecting these changes with pinpoint accuracy. And they didn't go easy on it either. They tested it using multiple real-world ECG datasets from patients who were actually experiencing some of the most dangerous heart conditions you can have, from atrial fibrillation all the way to life-threatening ventricular fibrillation. This was a real trial by fire.
So what happened? Well, the results were a resounding success. The algorithm worked. It successfully flagged the exact moment these dangerous arrhythmias started just by detecting that fundamental change in the heartbeat's pattern. It absolutely hit the target.
All right, so let's zoom back out. We started with this problem of alarm fatigue. We talked about the challenge of low-power devices, and now we have this brilliant, proven solution. So what does this all mean for the future of our health?
Well, the real power of this FLOSS algorithm comes down to three key things. First, it's domain agnostic, which is a fancy way of saying it doesn't need to be told what a normal heartbeat looks like. It just sees change. Second, it works in real time, as the data is streaming in. And maybe most importantly, it's so lightweight and efficient that it can actually run on the simple little processor inside your watch. And this really brings us to a pretty profound final thought. This isn't just about making alarms in an ICU better. This technology opens the door to a future where your watch isn't just counting your steps, it's silently, constantly watching the very shape of your heartbeat, ready to give you an early warning that could, quite literally, save your life.